Green River Valley, Wyoming Territory, summer 1847. While veteran trappers threw up standard fireplaces in 2 days using 400 pounds of stone, Swedish immigrant Lars Hedström was still hauling his 47th wheelbarrow load up the hillside. Black Pete Morrison called it wasteful. Trading post owner Samuel Lodge refused to help source materials, dismissing it as European nonsense. Hedström built what they mocked as a fool's castle, 3,200 pounds of carefully selected field stone, 8 feet wide with a 4-foot deep firebox, taking 3 weeks to complete versus the standard 2 days. Old Tom Bridger, 22 years in the mountains, advised him, "Son, you're preparing for a winter that ain't coming." Then February 1848 arrived. The bitter fortnight hit. Temperatures plummeted to 47 below zero, the coldest Wyoming winter in recorded history. Standard 400-pound fireplaces failed catastrophically, storing heat for only 2 hours before cabins turned deadly cold. Families burned furniture, consumed 5 cords of wood monthly, and 7 people died from cold. But Hedström's thermal mass system? It radiated heat for 10 hours after the fire died, used 40% less wood, and kept his family comfortable while neighbors froze. What did this Swedish stonemason understand about heat storage that frontier wisdom completely missed? And why do modern fireplaces still waste 90% of their heat up the chimney? If you value stories of practical wisdom that stood the test of time, make sure to subscribe. We've got more documented accounts worth remembering. Comment your city and time. We love reading where these documentaries reach. The morning sun cast long shadows across Green River Valley as Lars Hedström positioned his mason's level against the foundation stones, checking each placement with the methodical precision that had kept Swedish families alive through centuries of brutal winters. Around him, the sounds of rapid construction echoed from 3 other cabin sites where fellow trappers raced against the approaching season. Black Pete Morrison's hammer rang out in steady rhythm 200 yards downslope, already framing his fireplace after just 6 hours of work. Jim Cartwright had finished laying his hearthstones the previous evening, following the standard frontier pattern, a simple rectangular firebox 18 inches deep, built with whatever fieldstone lay within easy hauling distance. Hedström paused to wipe sweat from his forehead, studying the foundation he had spent 2 full days preparing. Where Morrison's fireplace would sit on a basic stone pad, Hedström had excavated 3 feet down, creating a foundation that extended 18 inches beyond his planned firebox dimensions. The other men called it excessive, but in Västergötland province, no stonemason would risk a thermal mass system without proper ground preparation. Stone needed support to hold heat, and heat needed stone to survive the night. "Hedström!" Morrison's voice carried across the valley. "You building a cabin or a damn cathedral?" The veteran trapper stood beside his completed firebox, arms crossed, shaking his head at the Swedish immigrant's elaborate preparations. Morrison's fireplace followed the proven American frontier design, 24 inches wide, 18 inches deep, built with roughly 300 pounds of local sandstone. It would heat adequately during typical Wyoming winters, which rarely dropped below 10 degrees below zero for extended periods. Trading post owner Samuel Lodge rode up the hillside that afternoon, surveying the various construction projects with the eye of a businessman who had outfitted dozens of frontier families. He nodded approvingly at Morrison's efficient work, then studied Hedström's foundation with obvious skepticism. "Planning something mighty ambitious there, Swede," Lodge commented, calculating the labor hours represented in the precise stonework. "Hope you're not expecting me to special order materials for some fancy European design." Standard frontier fireplace serves every family in this valley just fine. Hedström continued selecting stones from his carefully sorted piles, each rock chosen for specific thermal properties he had learned to recognize during his apprenticeship. Dense granite held heat longer than porous sandstone. Smooth river stones fitted tighter than angular fieldstone. Size mattered. Stones between 20 and 40 pounds created optimal thermal mass without structural weakness. "In old country, fireplace must work all night, or family dies," he replied quietly, not looking up from his work. "Stone remembers heat when wood becomes ash." Lodge snorted, wheeling his horse toward Morrison's sight. Fire's fire, Hedstrom. Heat goes up the chimney same as anywhere else. You're wasting time building for a winter that don't exist in Wyoming. By the third day, word had spread throughout the valley about the Swedish immigrants' unusual project. Old Tom Bridger, the most experienced mountain man in the territory, rode up to examine Hedstrom's progress. Bridger had survived 22 winters in the Rockies, including the legendary cold snap of 1835, when temperatures reached 30 below for a week straight. He studied Hedstrom's foundation, noting the precise angles and careful stone selection, then watched the immigrant test fit each rock before mortaring it permanently. Son, I've seen men freeze to death from overthinking their heating, Bridger said, settling into his saddle with the easy confidence of someone whose advice had kept dozens of newcomers alive. Standard fireplace heats a cabin plenty warm. You're preparing for conditions that ain't coming. This territory don't get cold enough to justify all that extra work. Hedstrom paused in his stone fitting, studying the weathered face of the legendary trapper. How cold does winter reach here? He asked. 20, maybe 30 below on the worst nights, Bridger replied. Happened twice in my time here. Standard fireplace handles it fine if you keep wood stocked and fire burning steady. The Swedish stonemason nodded respectfully, but returned to his work. In Västergötland, 30 below lasted for weeks, not nights. Families who trusted thin-walled heating systems became casualties of their own overconfidence. Stone thermal mass wasn't excessive preparation. It was survival mathematics proven by centuries of harsh reality. Over the following days, Hedstrom's methodical construction became valley entertainment. Morrison finished his entire fireplace system in 2 days, spending an afternoon hunting while his mortar cured. Cartwright completed his hearth and chimney in 3 days, dedicating the 4th day to chinking his cabin walls. Meanwhile, Hedstrom continued his precise stonework, building walls twice the thickness of standard frontier design. The mockery intensified as his fireplace dimensions became clear. 8 feet wide at the hearth opening compared to the standard 2-foot width, 4 feet deep versus the typical 18 inches. Most shocking of all, Hedstrom was building his chimney to extend 18 inches into the cabin interior rather than sitting flush against the exterior wall like every other frontier fireplace in the valley. Swedish folly, Lodge declared during his evening rounds, gesturing toward Hedstrom's growing stone mass. Man's building a monument to wasted labor, could heat 3 cabins with the stone he's using for 1 fireplace. Morrison and Cartwright often paused their own work to watch Hedstrom's progress, shaking their heads at the apparent excess. Fire heats air, air heats cabin, Morrison explained to younger trappers who gathered to witness the spectacle. Don't matter how much stone you pile up, heat still goes where heat goes. But Hedstrom had learned different mathematics in the frozen farmhouses of Sweden. Heat moved through stone slowly, storing thermal energy during active burning and releasing it gradually over many hours. Air heated quickly and escaped quickly through every gap in frontier construction. Stone heated slowly and surrendered its warmth reluctantly, maintaining interior temperatures long after flames died to embers. By late August, Hedstrom's fireplace neared completion. 3,200 pounds of carefully selected and precisely placed stone, representing 3 weeks of meticulous labor that other trappers had completed in 2 or 3 days. His neighbors called it elaborate foolishness, excessive European overcautiousness, applied to American frontier conditions that didn't require such extreme measures. The Swedish immigrant stepped back from his completed work, running his hands over stones that would soon face their first test. Winter was coming to Green River Valley, and every family would discover whether their heating systems could handle whatever the mountains decided to send. December 5th, 1847 brought the first serious cold snap to Green River Valley, with temperatures dropping to 15 below zero during the night hours. Black Pete Morrison woke twice to feed his fireplace, splitting kindling by lamplight to keep flames alive until dawn. The standard frontier design performed as expected: adequate heat during active burning, rapid cooling when attention shifted to sleep. Morrison burned through half a cord of seasoned pine in 5 days, matching his typical consumption during previous December cold spells. Jim Cartwright faced similar challenges in his newly constructed cabin, rising every 3 hours to stoke his fire and prevent interior temperatures from dropping below freezing. His 18-inch deep firebox required constant feeding to maintain warmth, consuming roughly 2 cords per month when cold snaps persisted beyond a few days. Both men accepted these requirements as normal frontier reality. Winter demanded vigilance, and survival meant sacrificing uninterrupted sleep for consistent heat. At Hedstrom's cabin, the Swedish immigrant burned his evening fire from 6 until 10, allowing the flames to die naturally as his family prepared for sleep. The 3,200-pound thermal mass absorbed heat steadily during those 4 hours, the dense granite stones reaching surface temperatures of 120 degrees. By midnight, when neighboring cabins had cooled to uncomfortable levels, Hedstrom's interior remained 65 degrees with no active flame. The massive stone system radiated stored thermal energy throughout the night, maintaining livable temperatures until morning without additional fuel. Samuel Lodge tracked wood consumption at his trading post, noting increased demand as December temperatures remained persistently cold. Standard frontier fireplaces consumed 6 to 8 cords monthly during sustained cold periods, compared to typical winter consumption of 4 to 5 cords. Morrison requested additional pine splits by December 15th, having burned through his planned monthly allocation in 10 days. Cartwright arrived at the trading post 3 days later, purchasing emergency firewood to supplement his depleted winter stores. Meanwhile, Hedstrom's wood consumption remained remarkably low. His thermal mass system required only evening burning sessions, using roughly 40% less fuel than conventional frontier fireplaces while maintaining superior interior comfort. The physics worked exactly as Swedish stonemasons had learned over centuries of harsh winters: massive stone stored daytime or evening heat production, and released it slowly over 8 to 10-hour periods, eliminating the need for constant fire maintenance. December 20th brought a more severe test when temperatures plummeted to 25 below zero, remaining at deadly levels for 3 consecutive nights. Morrison's cabin became barely habitable despite burning fires around the clock, consuming nearly a full cord of wood in 72 hours. Ice formed on interior walls 3 feet from his fireplace, and his family crowded into the single heated room, wearing coats indoors to maintain body warmth. The 400-pound stone mass of his standard fireplace retained heat for approximately 2 hours after flames died, insufficient thermal storage for extreme cold conditions. Cartwright's situation deteriorated even more dramatically. His fireplace, built with local sandstone that retained heat poorly, failed to maintain interior temperatures above freezing when external conditions reached 25 below. Water froze in buckets placed 4 feet from active flames. His family burned furniture and fence posts to supplement their rapidly diminishing firewood supply, consuming 4 cords in 6 days, while struggling to prevent hypothermia during sleep hours. Hedstrom's thermal mass system proved its superiority during this crucial test. His evening fires heated the massive stone structure to storage capacity, then radiated consistent warmth throughout the night, while neighbors fought losing battles against deadly cold. Interior temperatures in his cabin never dropped below 45 degrees, even during the coldest external conditions. His family slept comfortably under normal bedding, while other valley residents layered every available cloth and fur to survive the night. The technical differences became impossible to ignore. Standard frontier fireplaces released 90% of their heat directly up the chimney, heating air that escaped through gaps in frontier construction almost immediately. Hedstrom's design captured heat in stone thermal mass, storing thermal energy, and releasing it gradually into living space over extended periods. The 400-pound standard fireplace stored enough heat for 2 hours maximum. Hedstrom's 3,200-pound system maintained warmth for 8 to 10 hours after active burning ceased. Trading post owner Lodge observed the consumption patterns with growing concern for his customers' welfare and his own inventory. Valley families were burning through winter wood supplies at unprecedented rates, purchasing emergency firewood that Lodge had to source from increasingly distant locations. Morrison alone consumed 8 cords in December, double his typical winter monthly usage. Several families faced potential fuel shortages if cold weather persisted into January and February. Old Tom Bridger visited Hedstrom's cabin during the December cold snap, curious to observe the thermal mass system during actual performance conditions. The legendary mountain man arrived after midnight, when standard fireplaces would be cooling rapidly, and found Hedstrom's family comfortable in 60-degree interior warmth with no active fire. Bridger examined the massive stone chimney, noting how thermal energy stored in interior masonry continued radiating heat hours after combustion ended. "Never seen anything like it," Bridger admitted, running his hand along stones that remained warm to touch, despite no flames for 3 hours. "Stones still giving off heat like summer sunshine. How long does it last?" Hedstrom demonstrated by placing his palm against different sections of the thermal mass. "Big stones near fire stay warm until morning. Smaller stones cool faster, but system works together. Fire heats stone, stone heats cabin all night." December 28th brought temporary warming, with daytime temperatures rising above zero for the first time in 8 days. Valley residents assessed their situations, counting remaining firewood supplies and calculating consumption rates against remaining winter months. Morrison had burned through nearly 10 cords in December alone, leaving him with potentially inadequate fuel for January and February. Cartwright faced even more desperate circumstances, having consumed 12 cords in desperate attempts to maintain survivable interior conditions. Hedstrom inventoried his wood supply with quiet satisfaction. Despite maintaining superior comfort throughout the severe cold snap, his thermal mass system had consumed only 3 cords during December, leaving him with abundant fuel for the remainder of winter. The Swedish stonemason's elaborate preparation, mocked as excessive during construction, had proven its worth during the first serious test of valley heating systems. The pattern was becoming clear to anyone willing to observe objectively. Conventional wisdom about frontier fireplace adequacy assumed typical weather conditions that might not represent winter's actual severity. Traditional knowledge from harsher climates, dismissed as unnecessary overcautiousness, provided superior performance when conditions exceeded normal expectations. Stone remembered heat longer than wood burned, and thermal mass worked while families slept. February 14, 1848, the barometer at Samuel Lodge's trading post dropped to levels no one had witnessed during 9 years of frontier operations. Old Tom Bridger studied the instrument with growing unease. Recognizing atmospheric pressure readings that preceded the most devastating mountain weather. By evening, the first snowflakes began falling, not the typical Wyoming powder, but heavy, wet flakes that accumulated rapidly and promised extended duration. Temperature readings showed 20 below zero, with steady decline predicted through the coming days. What became known as the bitter fortnight began that night with a fury that caught even experienced mountain men unprepared. By dawn on February 15th, 3 feet of snow blanketed Green River Valley, and temperatures had plummeted to 35 below zero. Standard frontier fireplaces that had struggled during December's cold snaps now faced conditions that exceeded their fundamental design parameters. The physics of heat loss became brutally apparent as external temperatures dropped so far below interior targets that conventional heating systems could not maintain thermal equilibrium. Black Pete Morrison's 400-pound stone fireplace, adequate for typical Wyoming winters, began failing catastrophically during the second night. Despite burning fires continuously, his cabin interior dropped to freezing temperatures within 3 hours of letting flames die to embers. The standard thermal mass stored approximately 8,000 BTUs of heat energy, sufficient for normal cold snaps but inadequate when external temperatures reached 40 below zero. Heat loss through frontier construction exceeded heat storage capacity, creating a losing battle against hypothermia. Morrison woke every hour to feed his fire, splitting kindling with numb fingers by lamplight, burning through 2 full cords of seasoned pine in 4 days, while watching his family huddle in coats and blankets around the inadequate fireplace. Ice formed on interior cabin walls despite constant burning, and his water bucket froze solid 18 inches from active flames. The veteran trapper, who had survived 9 frontier winters with confidence, found himself facing conditions that rendered his experience irrelevant. Jim Cartwright's situation deteriorated even more rapidly. His sandstone fireplace, built with porous local stone that retained heat poorly, provided virtually no thermal storage during extreme conditions. Interior temperatures dropped below freezing within 15 minutes of fire reduction, forcing his family to maintain roaring blazes 24 hours daily. They burned fence posts, furniture, and tool handles in desperate attempts to generate sufficient heat, consuming 4 cords of mixed wood in 6 days while barely maintaining survivable conditions. Trading Post owner Lodge documented the unprecedented consumption rates with growing alarm for his customers' survival prospects. Standard frontier families typically burned 6 to 8 cords during entire winter seasons. Morrison had consumed 14 cords by February 20th, with 8 days of extreme cold remaining. Cartwright burned through 16 cords, exhausting his entire winter supply and beginning to burn structural elements of his cabin. Several families faced complete fuel depletion before the crisis ended. At Hedström's cabin, the Swedish immigrant's thermal mass system demonstrated its true capabilities during the most severe test imaginable. His 3,200-pound stone structure, heated during evening burning sessions, maintained interior temperatures above 45 degrees throughout the night, even when external conditions reached 47 below zero. The massive granite stones stored approximately 64,000 BTUs of thermal energy, 8 times the capacity of standard frontier fireplaces, releasing heat gradually over 10 to 12-hour periods. The technical superiority became mathematically undeniable. Standard frontier fireplaces required continuous burning to maintain heating, consuming 4 to 6 cords weekly during extreme cold while failing to prevent interior freezing. Hedström's system required only evening fires, using 1.5 cords weekly while maintaining comfortable living conditions. His family slept through the night without additional heating, wore normal indoor clothing during daytime hours, and never faced water freezing inside their cabin. February 20th brought the most deadly night of the crisis, when temperatures reached 47 below zero, the coldest reading in Wyoming territorial history. Morrison's family abandoned their main cabin, crowding into the single-heated room while burning everything combustible to maintain minimal warmth. Ice covered interior walls 3 inches thick, and their breath created frost clouds, despite active flames 6 feet away. The 400-pound thermal mass released its stored heat within 90 minutes of fire reduction, leaving the family in potentially fatal conditions during the remaining night hours. Cartwright faced complete heating system failure that same night. His porous sandstone fireplace retained virtually no heat once flames died, and his family burned their dining table, chairs, and cedar chest in desperate attempts to prevent hypothermia. Interior temperatures dropped to 15 degrees despite continuous burning, forcing them to wear every available garment and huddle together for survival. Their firewood supply completely exhausted, they faced the prospect of burning structural cabin elements or freezing to death. Hedström tracked interior temperatures with a frontier thermometer throughout the crisis, documenting performance that validated Swedish thermal mass principles under extreme conditions. His evening fire, burned from 6 until 10 o'clock, heated the massive stone system to 130 degrees surface temperature. By midnight, interior cabin temperature stabilized at 52 degrees. By dawn, after 8 hours without active flame, his cabin remained 46 degrees, while external conditions stayed below 40 degrees. The heat storage mathematics proved decisive during the bitter fortnight. Standard thermal mass stored 2 to 3 hours of heating, adequate for normal winter nights, but insufficient when extreme cold persisted for 14 days. Hedström's system stored 8 to 10 hours of heating, maintaining family comfort throughout extended periods when fire maintenance became dangerous or impossible due to fuel conservation requirements. Lodge's trading post became refugee shelter for families whose heating systems failed completely. Morrison's neighbors, the Henderson family, abandoned their cabin on February 22nd when their small fireplace could no longer maintain interior temperatures above zero despite burning continuously. 3 other families sought emergency shelter as their fuel supplies depleted, and standard heating systems proved inadequate for unprecedented conditions. Throughout the valley, the pattern repeated with deadly consistency. Conventional frontier wisdom, adequate for typical winters, failed catastrophically when weather exceeded historical norms. Families who trusted standard heating methods faced potential death from conditions their systems could not handle. The Swedish immigrants' elaborate thermal mass fireplace, mocked as excessive during construction, provided the margin between survival and hypothermia when nature tested all heating systems beyond their design limits. By February 25th, with 3 more days of extreme cold predicted, 7 families faced complete fuel exhaustion. Morrison burned his spare axe handles and wooden buckets. Cartwright began dismantling interior cabin walls for emergency fuel. Lodge rationed his remaining firewood inventory, knowing that standard frontier fireplaces would consume his entire supply within days, while failing to maintain adequate heating for valley survival. February 26th dawned with temperatures holding steady at 42 below zero, the 11th consecutive day of life-threatening cold that had pushed Green River Valley's heating systems far beyond their survival capabilities. Black Pete Morrison sat beside his dying fire, calculating the mathematics of death with the grim precision of a man whose fuel supply would not last through the remaining 3 nights of predicted extreme weather. His family had burned 18 cords of wood in 12 days, consuming their entire winter allocation plus emergency reserves, while barely maintaining interior temperatures above freezing. Morrison's 400-pound thermal mass had become a cruel joke during the extended crisis. The standard frontier fireplace stored heat for exactly 97 minutes after flames died to embers, measured precisely during desperate midnight vigils when every minute of warmth represented potential survival. His cabin lost approximately 15 degrees per hour when external temperatures reached 40 below, meaning that any interruption in active burning resulted in potentially fatal interior conditions within 4 hours. Sleep had become impossible except in 15-minute intervals between mandatory fire feeding sessions. Jim Cartwright faced even more desperate calculations. His family had exhausted 22 cords of mixed wood, burning furniture, tools, and finally structural cabin elements in increasingly frantic attempts to maintain survivable conditions. The porous sandstone of his fireplace retained heat for approximately 35 minutes after active burning ceased, forcing them to maintain roaring fires continuously, while watching their fuel supply disappear at rates that made survival mathematically impossible. Interior temperatures dropped below 20 degrees, despite constant burning, and ice formed on walls within arm's reach of active flames. Samuel Lodge documented the consumption crisis with the methodical precision of a businessman watching his customers face death from resource depletion. Standard frontier families typically burned 6 to 8 cords during entire winter seasons, but the bitter fortnight had created consumption rates of 4 to 6 cords weekly among valley residents. Morrison alone had purchased 32 cords since February 14th, more than most families burned in 2 complete winters. Lodge's entire firewood inventory, accumulated over months of preparation, would be exhausted within days if the extreme weather continued. The trading post owner found himself making life and death allocation decisions as desperate families arrived seeking emergency fuel. The Henderson family had burned their cabin's interior walls and flooring, creating dangerous structural instability while still failing to maintain adequate heating. 3 other families faced complete fuel exhaustion by February 27th, with no local wood sources accessible during the continuing blizzard conditions that accompanied the deadly cold. At Hedstrom's cabin, the Swedish immigrant continued his methodical evening burning routine, heating his 3,200-pound thermal mass system from 6 until 10 o'clock before allowing flames to die naturally. His family maintained normal daily routines, wearing regular indoor clothing and sleeping through the night without interruption. Interior temperatures never dropped below 43 degrees, even during the coldest external conditions, and his wood consumption remained consistent at approximately 1.5 cords weekly throughout the crisis. The technical superiority of thermal mass heating became undeniably clear through precise measurement and comparison. Hedstrom tracked his system's performance using a frontier thermometer, recording surface temperatures of stone elements at 2-hour intervals throughout each night. His massive granite fireplace retained surface temperatures above 80 degrees for 6 hours after combustion ended, gradually releasing stored thermal energy to maintain interior comfort until morning fires renewed the heating cycle. Morrison visited Hedstrom's cabin on February 27th, desperate to understand how the Swedish system continued operating effectively while his own fireplace failed catastrophically. The veteran trapper examined the thermal mass construction with new appreciation for details he had previously dismissed as excessive European overcautiousness. The 8-foot-wide hearth opening allowed complete combustion of large wood pieces, generating maximum heat output during active burning. The 4-foot depth provided optimal firebox dimensions for efficient fuel consumption, while maximizing thermal mass contact with hot gases. "How does stone hold heat so long?" Morrison asked, placing his palm against granite surfaces that remained warm 12 hours after the previous evening's fire. His own fireplace stones felt cold within 2 hours of flame reduction, providing no thermal storage during the extended periods, when fuel conservation became critical for survival. Hedstrom explained the principles with patient precision, drawing from decades of Swedish stonemason knowledge passed down through generations of harsh winter survival. Small fire heats big stone slowly. Stone gives back heat slowly, like summer earth stays warm deep below ground when winter freezes surface. He demonstrated by touching different sections of his thermal mass, showing how dense granite near the firebox remained warmest longest, while surrounding stones created graduated heat release throughout the night. The physics lesson continued as Hedstrom described stone selection criteria learned during his apprenticeship in Västergötland province. Dense granite and river stones retained heat longer than porous sandstone or fieldstone. Smooth surfaces transferred heat more efficiently than rough textures. Stone size mattered critically. Pieces between 20 and 40 pounds provided optimal thermal mass without creating structural weakness or excessive weight that could compromise foundation stability. Morrison studied the interior chimney construction, noting how Hedstrom's design extended 18 inches into the cabin rather than sitting flush against the exterior wall like standard frontier fireplaces. This interior thermal mass continued radiating heat hours after combustion ended, while conventional chimneys lost their heat directly to outside air. The Swedish system captured and stored thermal energy that standard designs wasted, converting fuel consumption into extended heating rather than immediate heat loss. Cartwright arrived at Hedstrom's cabin that afternoon, his family seeking emergency shelter as their own heating system failed completely. The young trapper examined the thermal mass fireplace with desperate attention to technical details that might save his family's lives. He measured stone dimensions, counted approximate weights, and studied the precise angles of the firebox walls that reflected heat forward into living space, rather than allowing it to escape up the chimney immediately. "Could I modify my fireplace?" Cartwright asked, knowing that his family faced potentially fatal conditions during the remaining nights of extreme cold. Hedstrom explained that effective thermal mass systems required complete reconstruction, not simple modifications to existing standard designs. The foundation needed excavation to 3-foot depth. Stone selection required specific density and thermal retention characteristics. Construction demanded weeks of precise work that could not be accomplished during active crisis conditions. Old Tom Bridger arrived at sunset, accompanying several valley families who sought shelter at the one cabin proven capable of maintaining survival conditions during the unprecedented weather crisis. The legendary mountain man studied Hedstrom's system with professional appreciation for engineering that exceeded his own extensive frontier experience. 22 years in the Rocky Mountains had taught him to recognize superior survival technology when weather conditions revealed the inadequacy of conventional methods. "Never seen heating work like this," Bridger admitted, watching Hedstrom build his evening fire with calm confidence while neighboring families fought desperate battles against hypothermia. "Stone's still warm from last night's burning. Standard fireplace is cold as the grave by morning." The survival mathematics had become irrefutable through 14 days of extreme testing. Standard frontier heating consumed 4 to 6 cords weekly, while failing to maintain adequate interior conditions. Hedstrom's thermal mass system used 1.5 cords weekly while providing superior comfort and safety. Families with conventional fireplaces faced death from fuel exhaustion or hypothermia. The Swedish immigrant's family maintained normal winter routines throughout the crisis. February 28th brought the final night of the bitter fortnight, with temperatures predicted to moderate above zero by March 1st. Valley residents who survived the unprecedented weather event would never again dismiss thermal mass principles as excessive European preparation for conditions that would never occur in Wyoming territory. March 1st, 1848, temperatures rose above zero for the first time in 15 days, ending the bitter fortnight that had tested every heating system in Green River Valley beyond its design limits. The final accounting revealed 7 deaths from cold-related causes among families using standard frontier fireplaces, while 0 fatalities occurred in cabins equipped with thermal mass heating systems. Black Pete Morrison emerged from his ordeal hollow-eyed and humbled, having consumed 34 cords of wood while barely keeping his family alive through the unprecedented crisis. Morrison approached Hedstrom's cabin that morning with the careful deference of a man whose certainties had been shattered by reality. The veteran trapper who had mocked elaborate European construction methods now studied the Swedish thermal mass system with desperate attention to technical details that might prevent future catastrophe. "Would you teach me how to build one?" Morrison asked quietly, his pride subordinated to his family's survival needs. The standard frontier wisdom that had served him adequately for 9 winters had proven potentially fatal when conditions exceeded historical norms. Jim Cartwright arrived later that day, bringing precise measurements and sketches of Hedstrom's fireplace dimensions recorded during his family's emergency shelter period. The young trapper had documented every technical aspect he could observe: stone weights, firebox angles, chimney interior dimensions, foundation depth requirements. His own heating system had failed so completely during the crisis that his family had nearly perished, despite burning 26 cords of mixed wood and furniture in 14 days. Hedstrom responded to their requests with the patient instruction of a craftsman who understood that knowledge sharing could prevent deaths during future extreme weather events. He began by explaining thermal mass requirements based on cabin dimensions and expected heating loads. A standard frontier cabin measuring 16 by 20 feet required approximately 2,500 pounds of stone thermal mass to store sufficient heat for overnight comfort during severe cold snaps. Smaller cabins needed proportionally less stone, but the minimum effective thermal mass for Wyoming conditions was 1,800 pounds. The Swedish stonemason demonstrated stone selection techniques learned during his apprenticeship in Västergötland province, teaching Morrison and Cartwright to recognize thermal retention characteristics that determined heating system effectiveness. Dense granite from creek beds held heat longest, followed by river stones worn smooth by water action. Porous sandstone and angular fieldstone retained heat poorly, explaining why Cartwright's original fireplace had failed during extreme conditions despite adequate size and construction quality. Foundation preparation required excavation to 3-foot depth, with 18-inch extensions beyond planned firebox dimensions, providing stable support for thermal mass systems weighing 30 to 4,000 pounds when completed. Standard frontier fireplaces built on simple stone pads would collapse under the structural loads imposed by effective thermal mass construction. Hedstrom showed his visitors the precise foundation work that enabled his system to store and radiate heat efficiently without settling or cracking. Firebox dimensions followed specific proportional relationships developed through centuries of Scandinavian heating optimization. Width should measure 8 feet minimum for complete combustion of large wood pieces that generated maximum thermal output. Depth needed 4 feet to provide adequate thermal mass contact with hot combustion gases while maintaining structural integrity. Back wall angles of 20 degrees and side wall slopes of 45 degrees reflected heat forward into living space rather than allowing direct chimney escape. The interior chimney design represented the most crucial element that differentiated thermal mass systems from standard frontier construction. Extending the chimney 18 inches into cabin interior rather than building flush against exterior walls created additional thermal mass that continued radiating heat hours after combustion ended. This interior stone mass captured thermal energy that conventional designs lost directly to outside air, converting fuel consumption into extended heating rather than immediate waste. Samuel Lodge commissioned Hedstrom to design an improved fireplace for the trading post after witnessing the consumption crisis that had nearly bankrupted several valley families. Lodge calculated that thermal mass heating could reduce his own firewood costs by 40%, while providing superior comfort for customers seeking shelter during severe weather events. The trading post owner, who had initially dismissed thermal mass construction as wasteful European nonsense, now recognized its economic and survival advantages. Old Tom Bridger spread word of Hedstrom's heating innovation throughout his extensive network of mountain men and frontier guides, describing the technical superiority he had witnessed during the bitter fortnight crisis. The legendary trapper who had advised against preparing for winters that wouldn't come now advocated for thermal mass construction among families settling in high-altitude or extreme climate regions where standard heating methods might prove inadequate. Spring construction began immediately as valley residents prepared for the following winter with new understanding of thermal mass requirements. Morrison excavated foundations for a 2,800-pound system designed to heat his cabin efficiently while consuming 60% less fuel than his failed standard fireplace. Cartwright planned an even larger thermal mass installation, incorporating lessons learned during his family's near-death experience with inadequate heating. 12 families completed thermal mass fireplace construction during the summer of 1848, following Hedstrom's technical specifications adapted to their specific cabin dimensions and available stone resources. The Swedish immigrant provided consultation and quality control, ensuring that each installation met minimum thermal mass requirements for reliable performance during extreme weather conditions. The winter of 1848 to 1849 provided the first test of valley-wide thermal mass adoption. Though temperatures remained moderate compared to the previous year's bitter fortnight, the improved heating systems demonstrated consistent fuel savings and superior comfort throughout the cold season. Average firewood consumption dropped 35% among families using thermal mass designs, while interior temperature stability improved dramatically during typical winter weather. Word spread throughout Wyoming territory about the Swedish heating innovations that had prevented deaths during the unprecedented winter of 1848. Territorial newspapers published technical articles describing thermal mass construction principles, spreading knowledge that would save lives in remote settlements facing similar extreme weather challenges. Frontier building guides published after 1850 began including thermal mass calculations and construction specifications. The Wyoming Historical Society later documented Hedstrom's cabin as a preserved example of frontier innovation that combined traditional European knowledge with American frontier conditions. The original fireplace stones still showed scorch marks from the bitter fortnight crisis. Physical evidence of the heating system that had maintained comfortable temperatures, while standard designs failed catastrophically throughout Green River Valley. Modern building science would eventually confirm what Hedstrom knew through traditional Swedish knowledge. Thermal mass systems store 4 to 6 times more heat than conventional fireplaces, radiate warmth 5 to 8 hours longer than standard designs, and reduce heating fuel consumption by 40 to 50%. The elaborate preparation that seemed excessive during mild weather became the margin between survival and death when winter tested all heating systems beyond their normal operating limits. Hedstrom recorded his own assessment in a journal entry dated March 15, 1848. In old country, winter teaches respect or winter teaches death. Stone remembers summer's warmth and gives it back when cold would kill. This is not waste. This is wisdom that waits for testing.